very much. Thank you very much, Dr. Amani Aspo, for that stimulating talk. I believe it will attract quite a lot of questions and comments, and we really thank you. What she has basically said is we do invest in research, science, and technology so that we can achieve financial independence here in Africa. The third speaker this morning is Christopher Smith. Christopher Smith is a consultant based at Cambridge University, and he's also a visiting professor at Murdoch University, Perth, Australia. Managing editor of Naked Scientist is a science and medicine radio show. Since 2006, Chris has published some popular books, and including the international bestseller, Crisp Packet Fireworks. His most memorable achievement to date has been delivering the world's first explosive science show on the banks of the Zambezi River in Zambia. He lives in Cambridge, and he's going to talk to us this morning about science and public translation. Chris Smith, the floor is yours.
Good morning. Thank you, Mikey. Everyone having a good time? Well, I'm, as you've heard, a medical consultant. I'm a virologist at Addenbrooke's in Cambridge. And that's what I do for half the week. The other half of the week, I run the Naked Scientists. Any Naked Scientist fans in? Anyone listen? A few people. Excellent. So I've actually got, I can win over another perhaps 100 people today. I suppose I should begin by apologising to anyone who's now sorely disappointed that I'm not actually naked. I can firmly reassure you, if I was naked, you'd be a lot more disappointed. Let's just deal with one thing that I'm sure is going through everyone's mind right now, which is, yes, we do this in the nude occasionally. In fact, I learned a very important lesson when I published this picture on the internet, which is never put anything on the internet that you're not entirely comfortable with someone editing within about 1 nanosecond. Because once this picture appeared, versions of it started to crop up in various places, and one of them had this dotted line coming down here from Helen's line of gaze in that direction. And then there was this big circle drawn around these two fingers down here with this speech bubble saying, "Is she trying to tell us something, Chris?" What you see in this slide is the old BBC studio in Cambridge. This programme starts life as a 1-hour radio talk show on the BBC, but it then also gets broadcast on network radio right across the UK. It goes to Australia on the ABC. We have inputs to Radio New Zealand. We have inputs to Talk Radio 702 and 567 Cape Talk in South Africa. We also have various outlets on community radio stations in a number of countries, including all over the US. This, combined with the website and the fact this also is made into a podcast, translates into a reach of at least 1 million people around the world every week. So this is one of the most downloaded science programs and most listened to science programs in the world now, and no other university has a radio show and a podcast and a website with this kind of impact originating from within the university. So this has been very good for Cambridge University because all of these programs are branded Cambridge University, and there's strong representation of Cambridge University researchers in this program. But at the same time, there's very strong representation of other voices. It's an international program, and so we represent scientists, doctors and technologists from everywhere in the world. It's one big conversation, and the public also have the chance to feedback on that. So why did I start this in the first place? I started this when I was a medical student, and in the middle of my medical degree I was doing a PhD, and in the middle of my PhD I thought, let's start a radio show, like you do. But why? Well, I can actually probably ask you to demonstrate this for me. Just raise your hand and keep your hand up if you've been to a scientific conference or a seminar or a workshop recently, not including this one. Put your hand up, anybody who's... Keep your hands up, that's nice. So, those people who've got your hand up, keep your hand up if you understood everything and could follow everything that was being said at that conference. Right, take a look around the room, everyone. 1, 2. Now, what hope have we got as scientists and doctors and people who try to inform policy if we can't even communicate with ourselves? At telling the public, at telling politicians, decision makers, and also telling the next generation what we're doing and why we're doing it. The communication of science is fundamentally the most important thing that we do in science. Because if you can't tell people what you're doing, why you're doing it, what you've discovered, then they're never going to give you any more money to do any more science. So communication is everything. And I wanted to get this going as a way of helping scientists to become better communicators, including me. I know I'm a much better doctor because of the things I learned doing this. And I know I do this well because I'm a good doctor. So I think there are lots of trade-offs between the two things. But I also wanted to have a way of raising aspiration amongst younger people, to show them what is exciting out there, what scientists are doing, so that we can get the next generation nurtured. So let me give you a little whistle-stop tour as to what we actually do on The Naked Scientist. So this is, as I say, the BBC studio. We've now got a new studio, it's a bit posher than this, but there are 2 or 3 presenters on this programme. Each week we take a look at what's coming up in the science journals, and we'll have a conversation and we'll interview the scientists who are publishing this work. Here's a couple of quick items that are coming out as big stories. There's a glass manufacturing company that have just announced a new crack-proof glass recipe for car windscreens. Here it is in action, as you can see. There's also a report from the South Pacific of the world's biggest seahorse that's been uncovered this week. Here it is. And the Russians, a little bit behind on their technology because they've spent all their budget invading former Soviet bloc countries. They're actually unveiling a new smartphone, camera phone this week. Looks like this, if I can get it to work. And unfortunately a little bit behind the time, but they have come up with this deluxe edition, which as you can see has this posh vibrating alert function on the side here. So we cover news stories, but we also critically interview scientists. And half the programme has scientists coming in to talk about their research. This is horse's mouth broadcasting, so people who are actively engaged in research come in and they talk about their work, but then they also talk with the general public who phone in, text in, tweet and ask various questions about the research we're doing. Another element of the programme is that you can give radio, which is a non-visual medium, a visual element by asking people to do experiments at home. And this is something we discovered is actually a very powerful way to get the message across. You can take very simple pieces of equipment and turn them into really quite powerful tools for communication. For instance, if you take a laser pointer like this one, which is a source of coherent light, you can actually turn it into a laser pointer powered microscope capable of resolving in quite considerable detail. Here's the physics. If you take a syringe and you suck up a droplet of water out of, you can do this out of the toilet. We did this on national radio. We went to the toilets around the corner from the studio. Rather unfortunately, someone had left something in the toilet which wasn't terribly pleasant, but it did mean the experiment worked quite well. But you can also do it with water from a puddle or a pond. You suck up some water, you express a little droplet of that water, and you shine light from a laser pointer through it. Because when laser light, or any light, goes from one medium, air, to another medium, which is more optically dense, water, it changes speed, or refracts, and that means it focuses. And anything that's in the water will cast a shadow. And when the light comes back out of the water, back into the air, it refracts again, and it focuses to a point, and that means the shadow also focuses to a point, but then it starts to spread out again. And if you put a screen in the way, somewhere like this, then actually you can project what is in the water onto the screen. If I roll forward one, if you could start the video for me, I've actually got a little bit of sequence of this, how this works. So here's our syringe. This is water out of the pond. This is our droplet. And the laser pointer, green one in this case, shining through it. And we then put a screen behind the water, and on the screen will be projected what is living in there. And you can see these are microorganisms that you are visualizing. In fact, each of those is something like 1 micron, or 1/1000th of a millimeter. You can see these little rings are the diffraction rings of the light going around the particles. But actually you have made your own microscope capable of seeing bacteria in some detail, just with a laser pointer and a syringe of water. It does work with other wavelengths of light. You don't just have to have green, so if you have a red laser pointer, then you can use this instead. So here's a red one. This bug here's got lots of energy, as you can see. Looks like it's had some acid or some crystal meth or something. But again, you can do some really quite high-level science and scientific explanation with nothing more complicated than a very cheap laser pointer. We also did, if I can we just go forward one? That's it. We also did some experiments which we wouldn't urge people to do at home, but which are nonetheless very good, again, at conveying interesting scientific principles. I'll talk you through this one. This is the Cavendish Laboratory in Cambridge, and that's a helium-powered rifle that fires bullets at about 1,000 miles per hour. This is a tube of gelatin in a Perspex tube. Gelatin is a really good analogue for adipose tissue. So can anyone put those two things together and work out what the question is that a listener sent in that we sought to solve experimentally? Well, the question was, of course, how fat would I need to be to fend off a bullet with my beer gut? Anyone, any suggestions? Very, yes. Well, the answer is you can do the experiment. So we did the experiment. I'll just go forward to this one. If you could, just before you run it for me, this is the end of the tube of gelatin. This is the trajectory the bullet's going to take. We're taking 5,000 frames per second, and the experiment is we're going to see how much the bullet trajectory is retarded by this distance of gelatin, and we can then extrapolate how big you would have to be to have your own inbuilt body armor. Okay, so let's just run the vid, please. You'll see the pressure wave arrive in front of the bullet here. Here comes the compressed air in front of the bullet coming in. The bullet then rips through the gelatin, and if we extrapolate that, actually you would have to be 75 centimetres to 80 centimetres of flab out front before a bullet got actually into your internal organs. But if you could literally be 75 centimetres fat, the reality is that you would be dead from cholesterol poisoning a very long time before a bullet got anywhere near you. Now, who remembers swine flu? Yeah, a very big problem. We started to get lots and lots of questions from people saying, well, actually, how fast does a sneeze travel? So we thought, well, actually, I've seen lots of answers, but I've not seen any decent evidence. So we thought, let's do the experiment and find out. So to do the experiment, what you need is a volunteer who will breathe a lot of pepper, because we fed this guy a lot of pepper. And this is a brick wall in Cambridge, and this is a piece of A4 paper. And the experiment is, we took pictures at 300 frames a second of him sneezing. If you could run the vid for me. If you're of a tender disposition, don't watch this. And we're then going to work out how long it takes the particles to go from one side of the piece of A4 to the other. Don't worry, he'll do it again if you missed it, just there. Here we go. Splurge. And one more. I love that sort of macro snot that goes over there. He's obviously a mouth sneezer, isn't he, this person? Now, can you roll me on one? So what we're able to do is to then break the footage on the camera down frame by frame. So you've heard of freeze frame photography. Well, this is sneeze frame photography. Okay, and what we can see here is that it takes about 3 frames for the snot particles, the snot trail, to go from one side of that piece of A4 across to the other. And that means we can actually now do the calculation, because that piece of A4 paper is 298 millimetres across, and the video is running at about 300 frames per second. So if we've got 3 frames at 1/300th of a second, how long does the snot take to do 30 centimetres? 3 over 1/300th, which is 1/100th of a second. So that means that actually, if you multiply the two together, you're doing 100th of a second, 30 centimetres, about 100 kilometres per hour, or 30 metres per second. That's the big particles. So actually, the small stuff probably is going at closer to 100 miles an hour. So if you answer either of those two questions as 100 kilometres or miles an hour, you're probably right. We actually wrote a lot of these things up. This is the book that was mentioned in the introduction, Crisp Packet Fireworks. We're just about to release the new edition of this, actually. It's going to be called Boom. And it's a whole lot of science experiments, a bit like the laser pointer powered microscope one that you can try at home. I'm quite glad that the publishers sent me this before they produced it for checking. Can anyone see the error? Well, rather regrettably, they can't spell scientists. Bit of a shame, isn't it? But probably quite informative. And we did get that corrected. We get lots of emails. The whole point of this program is people will contact us and they'll ask questions. We've got this question from someone who was actually, they sent me this at the height of the credit crunch. We jokingly said, this is someone who's looking to capitalise on their own internal assets, perhaps. Maybe even go liquid. I think the answer's about 8 to 10, based on my various workings. I know South Africa recently did the world's first penis transplant. We did that in Britain years ago, though, when we swapped Gordon Brown, Tony Blair around. But, you know. And then we got this one. There's a few fast people in the audience today. Does anyone a few people look like they're having a go at doing this right now. Anyone tried this? How would you find out? Well, we're not going to do the experiment, you'll be pleased to know. But we could do a thought experiment, couldn't we? So let's just do that together. You can actually use some simple physics to work this out. Whose laws do we need to invoke to work this out? Newton's laws. And how many laws did Newton have? What's Newton's first law? That's right, something's going to continue at a constant velocity unless a force acts on it. I'm paraphrasing slightly. What's the second law? F, force, equals m, the mass, times a, the acceleration. We're going to need that, aren't we? Because we're going to need to know, basically, if I just go... Can you roll me forward one? Because this is jammed. That's it. We want to try and work out... the force we're going to need is about 622 newtons, because the average 10-stone person at 63.5 kilo, the acceleration due to gravity is 9.8 meters per second. So if you multiply 635 by 9.8, we need a force of 622 newtons. And the other law we're going to need is Newton's third law, or I suppose in this case, third law might be more appropriate. But that is that for every action there's an equal and opposite reaction. So you push on the fart and the fart pushes back on you. That's the premise of doing this. Right, so the first thing we need to do then is, if we're going to work out a force of 622 Newton, that's F, and we need to know M, the mass of the fart, don't we? So I asked Jeeves, how much does a fart weigh on the internet, and it said a fart weighs 0.00037 kilograms. Must be a reasonably big fart. If we rearrange this equation, for A, how fast do I have to make the fart go? So I divide both sides of the equation by 0.00037 kilograms, so 622 divided by 0.0037 kilogram. Then what you find out is that you'd have to be farting at 17 million meters per second. Let's assume it's Christmas time, you've had a prodigious quantity of Brussels sprouts, and you can sustain a 1 second long trump. That means you're actually farting at 17,000 kilometers per second. Has anyone tried this? Because if you express that a different way, it's 36.5 million miles an hour, which is 5% of the speed of light. Probably not a sustainable form of propulsion. Actually, we put this on the radio, and some very canny person wrote to me and said there is a fundamental omission from your argument. Does anyone know, or can anyone highlight the point that was being made or what we've missed? Well, that is, if you're going to use this as a form of propulsion, you're going to need to have a very large supply of farts. Where are you going to store them? Well, presumably you're going to store them inside, and if you're going to store them inside, they're going to be under pressure. So as they come out, they're going to decompress, aren't they? Now, if you take a gas and that gas does work against the atmosphere, if something does work, what does it consume? Energy. So if you drop the energy of the fart from a higher energy state to a lower energy state, its average energy is low, so what happens to its temperature? It falls, or as this person pointed out, you will quite literally freeze your arse off. Now, all of this content that we make goes on this website, nakedscientist.com, which I set up just before I started my first medical job. I had a few weeks of summer holiday, and I bought a big jar of coffee, a couple of books on how you write coding for web pages, and started to translate everything to the site. This website's now grown to about 60,000 pages of content. Everything we do goes on here. All of the radio programs, as podcasts, are all here. They're all in a downloadable format. It's all free. We transcribe all of the interviews. This is an interview done for the week before last with Melissa Little. She's from Australia, and she's using stem cells to grow new kidneys in dishes. But all of the interview is transcribed into text format, and that means that search engines can readily find this content, but it also means, increasingly, people who don't speak English as a first language use this as almost a scientific learning tool, or they can come and check out their understanding by reading the text alongside actually listening to and downloading the audio. So you can download these things either as individual interviews, or you can download the whole program. We've also created an app for mobile phones. This is the Android one. We're working on the iPhone one at the moment, and it means that everything that's on the web now becomes accessible on a mobile phone as well. And the really natty thing about this app is that there's a little play button here, so you can either listen to all of our previous programs, or when we are live on the radio in any country in the world, this app will connect you to the web feed from that radio station via the server I've set up in Cambridge, so you can be listening to any program we're making on any radio station anywhere in the world, if you want to. This is the traffic for this website. These are just web pages, not podcasts, and each day there's something like 50 to 60,000 unique visitors coming to this website. And we're doing about 250,000 to 1/3 web page views every day. The podcast is doing, you have to look at this column as hits because these are purely downloads, anything from 20 to 30,000 program downloads per day of The Naked Scientist to every country in the world. I don't have any data for North Korea, no surprises there. Antarctica has 2 listeners, and I can only put that down to things like the British Antarctic Survey Research Station, who do have satellite broadband, so they probably download programs in Antarctica. But this means that this number of downloads tops up to 1 million a month, and it means that actually over time this is summed to more than 50 million program downloads just as podcasts around the world. Who are listening? Who are the listeners? Who is listening to this? Well, I've now surveyed something like 3,500 people who listen to these programs to find out who they are, and we've compared them over time. We've got data from 2010, 2008, and I've just done another survey, and the answer is that the audience isn't changing dramatically, but it is interesting. And what's interesting about it is that roughly half the audience have got a degree or higher level of qualification, but half the audience have got no qualifications in science at all. And that's very interesting, especially when about 6 to 10% of the audience have got a PhD in science. It's a very unusual audience, and we put this down to the fact that actually we are attracting and maintaining the confidence of scientists and researchers because the programs have incredibly strong scientific underpinnings, and the message is very clear. It's all supported by peer-reviewed references, but equally it's accessible to everybody. And science is also so subspecialised now that a person who's a physicist listening to a program on something biological is probably listening with a similar background knowledge to average members of the population anyway, which is how we think we're able to achieve this. But the fact that it's scientifically credible is highlighted by that audience. So what's my sell to you? Why do I think this is relevant to you? Well, something I'm proud of, which I started in the last year or so, is an internship program. We got to the stage now where we think we're reasonably good at making these programs. we've been pretty successful. So can we help other people to learn some of these skills? Because it occurs to me that I give good lectures, I get good lecture scores off my students, because I just take the things I've learned to do on the radio and I apply them in the lecture theatre. Same for writing grants, same for writing papers. And we realise that maybe we can help other people scientifically to do the same. So I've set up this internship programme, and what I'm doing is I've raised a whole lot of money from various sources, and I'm buying PhD students and early career scientists out of their PhDs right across the UK for 2 months. We put them into the Naked Scientists, and we get them doing what members of our team do. And they write news items, they interview people, they publish their interviews as podcasts, and they even put their content into our BBC radio programmes that then also go across the world. And at the end of 8 weeks, they also produce a whole hour of the Naked Scientists' main flagship programme. And that goes to an audience of up to 1 million people around the world. And what that means is that those PhD students who come to us with knowledge of their specialist area are able to then make a programme shining the spotlight onto that particular area of science, which we wouldn't have necessarily the resources or the ability or the knowledge of that sector to make a compelling programme about, and through them we're able to do that. And when we then send them back to their host institution, they are then able to share that knowledge, share that learning, and share those enhanced skills in communication with their colleagues in their host institution, but they also stay in touch with us so that we can continue to support them into the future. And this has been highlighted in the last week, because with the announcements of the Nobel Prizes, one of those prizes was in physiology or medicine, parasitology, the discovery of artemisinin and also the discovery of ivermectin. And one of our intern students from Nottingham was a parasitologist, and so he wrote a very nice piece which was in our news coverage last week about the discovery of those 2 drugs and that Nobel Prize. We've won a number of awards for doing this, so it is credible and it has been successful and it has been regarded by people as worthy and worth doing. We got the Royal Society's Cohen Medal for this in 2008, and it's been a huge pleasure and a privilege actually to make this happen. And we've actually got recognition from a number of other media, and the Daily Telegraph, who's one of our broadsheets in the UK, published their list this summer, this is in July, of the top 10 best, or the top 10 best ever podcasts, as they called it. And top of the list, here's Serial from America, and if you carry on down the list a little bit, under the science section, here we are. And we're actually the longest standing podcast on there. We were one of the first ever podcasts to exist. We were doing this back in 2001, actually, and it was only when it became mainstream in 2005 we thought, this is easy, we've been doing this for years. But what they say about us is that we managed to convey big scientific ideas and breakthroughs with clarity, wit, and a refreshing lack of lab jargon. I'd like to thank very much the following bodies who have supported me relentlessly in developing what we've done. The Wellcome Trust have given me a succession of very big grants, and the EPSRC, and especially Rolls-Royce, not the cars unfortunately, I don't have a Rolls-Royce car, but the aero engines, they give us a lot of money and support to make coverage relevant to the remit of Rolls-Royce. And UK Fast are the web hosting company who have helped us to serve up so many web pages over so many years. I was being thrown off of roughly 1 different web hosting company per week at the peak of this, because it just couldn't handle the demand of downloading this much traffic. I mean, we do something like 30 or 40 terabytes of data transfer a month. So it's a huge technology demand, and they've helped us, and Cambridge University gave me a home. Lastly, the people who I work with are absolutely super, and I couldn't do any of this without a team of very, very good production staff who also work with me on The Naked Scientist, so I'd like to acknowledge them too. And thank you very much for listening. And if anyone would like to come and talk to me afterwards about how you could become involved in being one of our trainees or join in the programme, I would love to have representation of some African voices in our programmes. So please do come and talk to me if you would like us to help you or you would like to work together. Thank you very much for your attention.